Thank you, Bernhard. Yeah, if you want, you can of course switch in your camera, but you don't have to. Generally, we're going to do it similarly as in the main room. We're going to have well, several blocks, topical blocks, and we're going to have short rounds of questions that we tackle at the end of each block. You're free to always write your questions directly in the chat. And let's see, we are yeah, behind schedule, and let's see how much time we will have at the end, but we will try to be quick in order to maybe have a short discussion round at the end still. But please post all your questions that you have in the meanwhile in the chat, and we will try to answer them whether directly in the chat or directly after in short sessions. Good, I will now share my screen. I hope you can see it.
Yes, we see your screen.
Yes. Now you should also see a presentation.
Yes, we see your presentation.
Okay. Good. So we are a bit behind schedule. That means that I will try as the first one to already go in quickly. Actually, the program that we have foreseen now is that we start with an intro to the HotMaps database and toolbox. Then, so it will consist of a short presentation plus also a guide through the tool directly. So as I said, you have the website. You can also go into the tool yourself. Then we're going to have a preview of the Animaps EMP-E. So it's the data visualization tool, and also hear about which calculation modules are coming up within Animaps. Actually, we have a lot of calculation modules already developed in course of the HotMaps project, and some of them or several calculation modules will be added then via Animaps. Then we're going to have a presentation by Eric about the data sets and the quality check process for the featured data sets. And after that, Bernhard will show us how data from Animaps can be reused in HotMaps, so that you have an inspiration about one possible way of using the data that is offered in Animaps. Just very quickly, on HotMaps, I will not go through the entire presentation, just that you know, HotMaps, what is it? It is actually a toolbox to support public authorities, energy agencies, and planners in strategic heating and cooling planning at various different levels. Actually, one main pillar is that it all is open source, so you can download everything. You can download all the source codes. It's not only open access; it's open source, so you can have everything. And it's a code which it's a license which allows you to use it in any possible way after, yeah, as you like. And of course, it's a big consortium that has developed that, 16 partners from different countries around Europe. What you also should know is currently the tool is at TRL 7, so that was actually the aim of the project, and we are currently trying to get to the next level, to TRL 8. We have currently handed in the project in order to go there. HotMaps consists of 3 different parts. One part is the database, meaning that for a lot of different data that you need for heating and cooling planning, you have default data provided by HotMaps. You have the toolbox, which we're going to have a look at. It's actually a visualization tool, plus you have calculation modules to analyze different parts of the heating and cooling systems. And you have a wiki where you have various information on the tool, on the data, and how to use it. Animaps, as Julia has already said, is a follow-up project of HotMaps. That means that we are basing on what we have developed in HotMaps and further develop data sets on the one hand, plus also further develop calculation modules. Here is just a graphic. Actually, the tool provides a lot of different calculation modules that you can analyze to with which you can analyze different parts of the heating cooling system. Here is just to figure how it is used then, or it can be used in order to come up with scenarios for heating and cooling for future states or different states of heating and cooling with the different modules. So you use different modules one after the other. Now let's go into the toolbox so that you also get first impression of it. Actually, it's, as you can see, it's web-based. So it's a web page. And actually, it's, as I said, a visualization tool. So you can move on the map, you can zoom in, zoom out. And also, I will make this a bit bigger. So you have here a bar with options. Actually, you have you can connect, you can log in, have your own credentials, your own space that is not shared with anybody else. You can go to a certain location, and here you have the layer section. So then there pops up the layer section on the right side. Also, you have here different levels of selection options. So you can, for example, let's choose NUTS 3, which means, yeah, you probably all know this political structure, regional distinction, and then you can select a region. And then all that you do is done for this selected region. For example, to show data, actually, if you're in the layer section and here on the left side on the layer section, you see all the data that is geographically allocated or geographically explicit data that you can see then also and work with. You can also upload your own data, and you have sections for buildings, different data for buildings. I just checked the heat demand density map, default map. You have data for industry. Let's check the industrial excess heat. You have population, you have renewable energy potentials. Let's, for example, choose the wastewater treatment plants. You have also climate data. And then if you have selected the zone, then you can load results for the zone. You see it on the right side. And for the data sets that you have selected, you see several indicators, as for example, the overall heat demand that is in that region. Actually, of course, as you might, as you know, it's actually a sum of the data that is in the platform. Now what I've selected is all default data. So yeah, it's an estimation. You have also the excess heat potentials that are in the database currently, a sum of it, and also the sum value of the wastewater treatment plants. What you can also do then in the layer section is actually to go to calculation modules. Here you see all the calculation modules that have been developed in course of the project. We have 3 parts of it. It's one part of the modules are developed in order to analyze the demand side of the systems, the supply side of the systems, and then we have some of them that are not integrated in the toolbox, but they are standalone. So you can download them, download the code, and install it on your own machines and use it there. And just to see, for example, one of the modules here, I chose one where you can very simply and quickly just analyze potential district heating areas. It's actually, you have 2 threshold values, one for the heat demand in a certain hectare element, and on the other hand, hectare elements that are in line with that, at least above this threshold, and then the sum of it of all the coherent ones, another threshold. And what we see here, for example, is that to these default values that are set here, it's around 30% or a little less than 30% in that region that I have selected that that are in line with that. And we can see here, for example, also we can see here where those regions are. Yeah, there are various different calculations modules in, as you will see, and we have, for example, as well another module that I just quickly show you, because Bernhard will use it then at the end in the demonstration. We have a calculation module for the supply side. It's actually solar, thermal, and PV potential. Actually, what the module does is to calculate the overall potential for the supply from solar systems. So you can choose the share of the area. Oh, it's actually focusing on rooftop, so it uses the footprint of the buildings, a map of the footprint of the buildings, plus also a solar irradiation map. And you set then a certain share that is used by PV and a certain share that is used by solar thermal. You give economic input data and efficiency input data, and what you get then actually is the overall potential for PV, solar thermal plus costs. Yeah, actually, and then also here on top you have the wiki button, so you can go directly to the wiki, which we have translated in all EU 28 or former EU 28 languages, and you have here a link and an explanation to all data sets. So part of the default data is located directly in the tool. The GIS or the geographically explicit data is in the layer section, but we have more data, and you can also download all that via these links here. Then general tool functionalities, you have a detailed explanation of all the calculation modules here, and also guides how to use it. So that's actually the tool, the hot maps tool. You will also receive further links and information on it. Now, just quickly, I'm going to show you also. Sorry, I'm going to stay here. Actually, the EDMT, actually you can access it easily via the gateway or directly. If you go to beta nmapsopenair.eu, you will see here the featured data sets. We will also see that later on. Then you have all the data sets here. And if you, for example, then click to that data set, then you will see a summary of it, plus also the tool. And here, if you click here, you get directly to the visualization of that data set in the EDMT. So that's how the EDMT looks like. So it's also a visualization tool. You have also these options here to choose the selection size, actually. Data sets, you can visualize it, and what is also going to come actually is calculation modules. So different calculation modules to those that have been developed in hot maps will be available then here. Actually, the tool currently is in a development phase. A first version is online, and you can have a look at it. Here, I just want to quickly give you an overview of which tools are going to come, which calculation modules in course of Nmaps. We are going to have, I think it's 5 calculation modules. Just a very quick overview. Heat learn is one of them. The aim is to have a quick estimation of heat demand density of buildings in a selected area. What it does, it is uses measured data from buildings from one canton of Switzerland, and from that data set developed a regression module in order to estimate then the heat demand for other areas based on location and land use data. And you will also find, I mean, Julia already has posted the links in the chat, but you will also find it in the presentation here directly, the link to the video presentation. Refurbished scenarios is another tool that is going to come up. Actually, the aim is to show a quick estimation of heating cooling saving potentials in buildings of a certain type in a certain defined location. So actually it uses data from the Tabula database. So it only focuses then on residential buildings. And actually you can choose the type of building that you want to analyze, the region where it is. You can also then choose which level of refurbishment is chosen or should be calculated, and then you see the effect of that in that certain area where you are located. Then we have another one, heating degree days, cooling degree days. Actually, this is to have a quick estimation of changes in heating degree days and cooling degree days due to climate change in a selected area. It actually uses the Eurocordex dataset, which is a breakdown of the, I think the RCP climate scenarios to the local level actually, so to each hectare element in Europe, and it uses actually that data set and calculates heating degree days and cooling degree days out of it, so that you can see what those scenarios mean in terms of heating degree day, cooling degree day change in a selected location. Then we have the DHExp-Pot module. It's actually a further development of one of the calculation modules that we have in hot maps, the district heating economic assessment module. Actually, it calculates regions where district heating might be feasible due to the fact that it is that the distribution costs in that region is below a certain defined threshold. And we have the building heat load. It's actually to estimate hourly profiles for space heating demand for a certain building type in a defined location. So actually it uses Episcope building data and Copernicus climate data together with the resistance capacitance model in order to derive hourly profiles. Yeah, that's it from my side. I don't know if we have questions so far for that block. I don't know, Bernhard.
Currently, we have no questions.
Okay.
So far.
Fine. So let's go directly to Eric. And as we said, sorry, I just have to put that away. Yeah, you can always post your questions. And
there came up a question.
Yes.
How are publications added to the database? Is it an ongoing process?
You mean to the gateway? Is it a geteway?
The gateway, yes.
Okay, yeah, no, the gateway actually, yes, this is an ongoing process. As far as I know, the publications that are, so the gateway, as the name says, it's only, let's say, it's not directly a database, but it's a link to other databases. So actually, if a publication is published by a certain publisher, then it should automatically be found by the gateway. So the gateway then directs to this publication. And it's more or less a search engine and a link, search and link engine, actually. So it's an ongoing process, regularly updated.
Yeah, I believe it uses keywords. So if you add a keyword to a publication like energy, it'll automatically route to the EnerMaps open air gateway as well.
Yes. Okay, Eric, the floor is yours.
All right. Thanks, Marcus. And yeah, good morning, everyone. My name is Eric Wilczynski. I work at Euroc Research in Northern Italy. And today I'll be presenting on the dataset collection and quality control processes that were undertaken by the EnerMaps project as part of the first work package. And, next slide. So first I'll begin by introducing why EnerMaps is an important project for energy-related data. I'll then go through the dataset collection process using the initial inventory creation. Then I'll discuss the quality check process and finally discuss the feedback gathering process that was conducted. Next slide. Okay, so the core of EnerMaps is the data itself, which is the focus of this presentation. Energy data, it's often difficult to find, it's located in different repositories, fragmented, and that can result in project delays and result in lost time and money. And EnerMaps seeks to address these issues by providing a quality check database of crucial energy data that will communicate and disseminate data effectively and efficiently using practices to make the data more findable, accessible, interoperable, and reusable or fair. As such, data is central to the EnerMaps project, and the EnerMaps data management tool will be a hub for energy data. So the purpose of the first work package of the project was to identify and select the initial data sets, which will form the core of the EnerMaps data management tool, and then to validate these data sets. Next slide. So as mentioned, the main goal of work package 1 was to create the initial inventory of data sets that will be added to the tool. Many of these data sets will undergo a quality check process to assess the quality and consistency. However, there were some criteria that acted as a jumping off point for selecting the data sets. First, there was a focus on renewable energy data, since this would ensure that the platform would be useful in future trends in Europe's energy research. Obviously, we're going more renewables, so we wanted to have that being a main focus. In addition, there was an emphasis on data from national and European statistical offices, such as Eurostat and European Environmental Agency, due to the high quality of these data sets. And then finally, around 15 of the data sets were required to be from recent publicly financed research and innovation projects. So projects that may have produced data sets as part of their outputs. Data sets from these projects would especially benefit from NRMaps since they're not always well known, or they're not easy to find. In some cases, they're not easily downloadable or available for download at all. So NRMaps would provide a sort of avenue for them to disseminate and share their data sets with the greater research community. Next slide. So we took 2 primary steps in assessing the data demands of the energy research community. First, we gathered insights on crucial energy data categories by conducting a review of journal papers, conference views, and similar articles on the common data sets and data demands for energy research, taking note of the types of data used in these data sets and any data demands that stakeholders may have mentioned needing but not having access to. And second, we conducted a stakeholder analysis to identify sampled experts who were then interviewed to assess their energy demands. The selection process was designed to ensure a diversity in experts, both in terms of their field and their demographic background. And they were then asked to provide examples of the data they required most and to describe their user stories for their data, energy data demands and issues. Next slide. Okay, so when selecting the data sets for the inventory, we consider the following principles. First, we consider data demands of the energy community that were identified in the previous step, including specific data sets that were recommended by experts from the expert interviews. And second, we consider the project prerequisites that were previously mentioned, including an emphasis on renewable energy data, ensuring that a significant portion were from public R&I projects, and ensuring that they were either focused on the Europe or contained the European region as part of their geographic scope. And finally, we wanted to consider a diversity of categories, ensure that a variety of data was selected, so it wasn't all just leaning more towards one specific type of data category. Okay, next slide. All right, so next I'll go over the quality check process or QC process, sometimes even the quality control process. We just sort of went between terms. This process is important that it verifies that the data sets are accurate, consistent, and that its creators were transparent with regards to the creation of the data set. Next slide. Okay, so the first step we had to do before starting the quality check process was categorizing the data sets into 3 levels, which determined the extent of the quality check process each data set underwent. So level 1 data sets were primarily data sets that were identified by experts, and they only underwent a cursory portion of the QC process, including a review from experts, a check for metadata, and whether they were made, and they'll also all be made available to users on the NRMaps Kialo social network. And then level 2 and 3 data sets underwent the same steps as level 1, but they also had a more involved investigation in their data and the documentation that was included with the data sets. And finally, level 3 data sets also underwent an additional step and received a high-level comparison between 2 similar data sets. So I'll quickly go through some of the core of the quality check process. There was the methodology check, which is more or less just a documentation check for the presence of whether the methodology for producing the data set was included in the documentation for the data set. Completeness control, which is just a quick analysis of the data set, check for blank or null values. The statistical accuracy check, which was similar to methodology check, in which we refer to any documentation that may have been available for the data set's creation to see if there was any elaboration on the statistical accuracy of the data set. And then finally, a consistency analysis, which was conducted by testing the correlation between two data sets. So the data set and plus a similar data set that may have a logical correlation with it, either the same measure or it measured something that should be logically correlated, like energy consumption and population density, something like that. Next slide. And finally, the stakeholder feedback process was a vital component of this work package and was a key contribution to the three deliverables that are listed here. As mentioned, external experts were interviewed in order to assess energy demands and gather user stories. These user stories were also used when guiding the development of the EnerMaps data management tool and its features. An internal focus group meeting and review session among the consortium members on the dataset collection process was conducted to gather feedback on the process and results. And finally, another group of external experts were interviewed to review and provide feedback on the dataset selection and quality check process. And the feedback received from all these tasks were used to improve the dataset inventory and quality check processes. Next slide. And yeah, that concludes the presentation on data collection validation, and thank you for your attention.
Yeah, thank you, Eric. Thanks a lot for this intro to what you did actually for the quality check. Actually, I didn't have a look at the chat. Bernhard, do you see? I just see the questions.
No, there are no questions now.
Okay.
Yes.
Okay, so there's the old questions. Good. So let's go into your part. I will stop sharing my screen.
Then I will start sharing my screen.
Mm-hmm.
And I hope you can see it now.
Yes.
Yes. Okay. So welcome to my part of the presentation. My name is Bernhard Meyer. I work at eThink as a researcher, and what I want to show you now is an exemplary an example of how to use the featured datasets or one of the featured datasets in your own research. And you already know the HotMaps toolbox. And as my colleague already introduced the calculation module for PV potential, I want to introduce you how to use your own datasets from the EnerMaps gateway in your HotMaps toolbox calculations. I will do the calculations on my current location. It is Vienna. And first, I'm going to select the NUTS 3 level. And I will also connect to my account where I can load my own customized layers. And as my colleague Markus already introduced, you can see the heat density maps here and the calculation module, the solar, thermal, and PV potential. And when we are going down there, these are all the input variables we can select, and also our input layers. So we have here the building footprint layer and the solar radiation layer. And both of them are default layers in the toolbox. But for example, if you want to use your own solar radiation layer, your own modified solar radiation layer, or more actual, more up-to-date solar radiation layers, I first go on the layer and have a look on the layer which is already in the toolbox. For this, I click on the information symbol and I open the link here to have more information about the default layer. And you see here, this is a GitLab README, and you see here, this is the annual solar radiation derived from monthly raster data on solar radiation on optimally inclined surfaces in kilowatt hours per square meter. But let's say these are all data sets, and I look up in the EnerMaps gateway, and as I know, there is a PV GIS solar radiation data here. So I have a look at it, and I know the summary already, the Nmaps tool here too, and the link where I can download the data set, which leads me to the data provider. And the data provider offers solar radiation data. And in this case, I see here the format, the projection of the layer, it's WGS84, and the grid cell size. So let's use the yearly average global irradiance on an optimally inclined surface. So what I'm going to do now is to download the dataset and save it on my computer. I already saved it. And now I can open the dataset, and I'm going to unzip it. I already did that before, and see here the dataset. The datasets are normally in a format where I cannot use them for my own research. So very often, or most of the time, I have to modify them. Some of you, as we saw in the poll before, in the beginning, some of you have experience already in GIS software. I will show you a quick or I will show you how I modify them in the GIS software QGIS. QGIS is open source software. It's very powerful, and you can visualize and modify the georeference datasets. So let's load the dataset into QGIS, and it should load the layer now. It takes a while, and as you see here, this is our layer. We have to know which requirements our datasets for hot maps should fulfill. So I go back to the hot maps toolbox, and what I would need is an example layer. For that reason, I use a calculation module. It's not the main purpose of this calculation module is not for that what I'm using it now, but the side effect is that I can download a small specific data set from my area. So I have here, I conducted the calculation module, and I get here a example layer. So I'm going to download my example layer, download it, and open it again and load it into QGIS. So again, what you see here, this is my example layer, and this is my new dataset layer. Let's have a look at my example layer, the characteristics. I see here there is the projection 3035. And as we know from the description from the dataset, this map used the projection WGS84. So what I have first to do is to transform the projection from WGS84 to EPSG 3035. I will use the transformation tool from the reprojection tool from the toolbox. I use my layer, my dataset. The source projection is WGS84, and my target projection is EPSG 3035. And now I'm going to reproject it. It's doing something, as you can see here in the command line. It should be very quickly, actually. I guess because there are so many things running now on my computer with Zoom, it takes a little longer, but should be finished soon. Yes, correct. And now you can see the reproject layer, and in our, as we needed for our purpose. But let's have a look again in the dataset, in the layout dataset. Another requirement we must fulfill is the pixel size. The pixel size is 100 per 100, and from the layout layer. And what we have currently in our dataset is a pixel size of 2121. This we again have to bring to the pixel size we need. So what I use for that is upsample it. There is a tool already in the toolbox too, where I can take my reprojected layer. I decide for a method for upsampling it, and I want to be the extent of my layout layer. The pixel size is 100, what I want to use, and I go for the nodes. So let's have the upsampling it, the layer. It should take also not very long, actually. So you can see it's doing something. So probably for some of you already know the QGIS, some of you don't. If you're interested in, it's a community supported project, and they have good tutorials about using it. So I finished it. There are some errors we can ignore, and let's deactivate our reprojection and our input layer. And what you can see here now is our layer for the defined region we want to have. Let's have a look again in the dataset. We have here that the dataset is the average, the yearly average in watt per square meter. In the toolbox, now I cannot see the tabs here. Okay. In the toolbox uses the annual solar radiation in kilowatt hours per square meter. So actually we have to modify them in the last step. What I do is here do a raster calculator, take the raster, and because this is an average value, I scale it up by multiplying it with the hours per year, and divide it by 1000 to get the kilowatt hours. And I save it last on my computer and do the calculation. And now we have the solar irradiance for my selected region. What I can do now is to open again the toolbox, go on my account, and let's delete this old one, upload my solar irradiance, my modified dataset, upload it, select it as what it is. It is the solar radiance, and upload to layer. So what I have now here is the new layer I modified and uploaded in the toolbox. And now I can go to the calculation module, go for the calculation module for the PV potential, and set my inputs as I want them. And here I see the default layer, and I can also use now my layer I created. So when I run the calculation module for my selected region, I will see I guess this is the old one, must be this one. Yes, as you see here, it takes a while, the calculation module, but it should then show me the results with my modified, more up-to-date layer. So the main ideas I wanted to show you here, the key ideas is not the use of cookies, but how to that you an example of how to use your own data sets for your own research. You have to modify them and upload them in your selected tool. And for example, the Hot Maps toolbox. And here you can see the results. So I see here Marcus.
Yeah, thanks a lot, Bernhard, for this presentation to show us how such a use of a dataset from Nmaps or part of a dataset of Nmaps could be, for example, used in hot maps. We had several questions. I tried to answer all of them that I could answer. One was actually, now I couldn't answer. It's actually what is meant by upsampling.
Upsampling, yes, it's a good question. Let's go into the when I look at the data set, I got from the external link. They have a sample size of I don't know, 1 kilometer or one value per square kilometer. But for the Hot Maps toolbox, I don't need a raster in pixel resolution of 1 square kilometer. I need a pixel resolution of 1 hectare, so 100 multiplied by 100 meter. And for this reason, I just make 1 pixel. I divide 1 pixel into several other pixels, more pixels. Let's say you have a picture and you take every pixel and multiply them by 1,000, then you have more pixel per origin pixel.
And actually, it's sorry. So it's, you have for the 1 kilometer per 1 kilometer, you divide it to 100 per 100 meters. So you have 100 pixels then, and each of those pixels has the same value then.
Yes. For example, here you see the original a pixel, and this pixel now is not 1 pixel. This pixel is now 100 per 100 pixels more. And they all have the same value, but they are the same pixel. And for this, you have to upsample them. Okay.
So it's actually a method that is implemented in QGIS.
Yes, yes.
But it's not. Yeah, all values, or the values are all the same.
The values are still the same, but the format is different to use them in the Hot Maps toolbox.
Yep. Okay, we have another question. It's default building footprint uses OSM. Yes, I guess you can also upload your own building footprint layer. Yes and no, actually, because in the toolbox itself, there is no, not directly a footprint layer in. So what we have in is, for example, a heat demand density map that uses the OSM footprint layers in order to, let's say, allocate the heat demand from the national level to the 100 per 100 meter level. But the footprint layer itself is not in. And similar also for the irradiation layer, it's actually, or let's say the footprint layer that is in is not, is as default in the background, but not as, but you cannot change it. But this is a good point actually, because we are further developing the tool. So this is a good point to note down that also the footprint layer should be changeable. Yeah. So I will try to motivate the developer team to push that. Another question, will Nmaps follow the same logic in terms of projection and cell size? I think so. Actually, I'm not sure about the projection. I'm not sure about the projection actually, but cell size is definitely the intention. However, we also have different cell sizes for different data sets in hot maps. So we try to have several of them on the 100 per 100 meter level, but some of them are also included in the kilometer per kilometer cell size. So, yeah. Yeah, do you have any more questions? We're actually at the end of the program. We hope it was interesting for you. You learned something for your daily work or an inspiration. I mean, we are also slightly above time. So in that sense, if you don't have any further questions, we thank you very much for your attention. If you want to receive further information or also participate in a hot maps training, please just drop me an email or and you will receive further information. Yeah. No further questions. Thank you very much.
Thanks a lot.
And enjoy the rest of the EMP-E. Bye-bye.
Thanks, everyone. Ciao.
Ciao. So, sollen wir im Main Room zurückgehen? Also